Okay, so now we're still doing 5.1. Now we're doing factors of a number and prime factorization. So if I have 2 times 3, these are the factors of 6. So you can do it like this. What are the factors of 10? Or some factors of 10? 2 times 5 is 10. So 2 and 5 are factors of 10. Okay? So we're going to make something called factor trees to find the factors. So if I go down here to the very bottom of the page, it says list all the factors of each number. So I have 35, and I go, what times what is 35? Well, because it ends in a 5, I know it's 5 times something. So 35 divided by 5, 7. So 5 times 7 is 35. So my factors are 5 and 7. And then we have something called prime factorization. It just says we have to use the factors and multiply them together to get whatever number we've started with. Oh, that shouldn't be 12, that should be 60 there. So here, if I want to do prime factorization, I just take this number, 35 equals, I put my two factors, multiply them together, and then I say, how many of each one do I have? I have 1 5 and 1 7. And when they're ones, you don't actually have to write the ones, you can just go 35 equals 5 times 7. So let's do 48. Well, 8 is an even number, 0, 2, 4, 6, or 8. So I know I can divide it by 2. 48 divided by 2 is 24. Can I make 2 smaller? No. 24 is an even number. It ends in a 4. So I can go 24 divided by 2, which is 12. Can I make 2 smaller? No. Can I make 12 smaller? Yes. That's 2 times 6. Can I make 6 smaller? Yes. 2 times 3. Can I make 3 smaller? No. Okay. So my factors are 2 and 3. I don't write 2, 2, 2, 2, and 3. I just have to write the number once. Now if I want to do my prime factorization, I just have to write my big number up here, and I write my two factors, and I say how many 2's? 1, 2, 3, 4. And how many 3's? Just 1. So I don't have to write the 1. And what that means is if I go 2 to the power of 4, and to get that little 4, I push this button here with the box. And then it puts a little box, and I can put any number I want in there. 2 to the 4, go over, multiply it by 3, and it equals 48. Because that means 2 times 2 times 2 times 2 times 3 is 48. Let's look at 56. 56 is even, because it ends in a 6, so I know I can divide by 2. 56 divided by 2 is 28. Can I make 2 smaller? No. 28 is even, it ends in an 8, so I can go 28 divided by 2 times 14. 2 is, I can't make 2 any smaller. 14 is 2 times 7. Can I make 7 smaller? No. So my factors are 2 and 7. And my prime factorization is 56 is equal to 2 times 7, 2, 7. And I say, how many 2's? 1, 2, 3. How many 7's? 1, but I don't put the 1 there. 75. It ends in a 5, so I know it can be divided by 5. So 75 divided by 5, 15. Can I make 5 smaller? Nope. 15 is 3 times 5, and I can't make these any smaller. So my factors are 3 and 5, and my prime factorization I go 75 is equal to 3 times 5, and I say how many 3's? 1. How many 5's? 2. That's kind of fuzzy. Let me fix it. Yeah, that's better. Okay, 30. 30 ends in a 0, so I know it's 10 times something, so 10 times 3. 10 is 2 times 5, and these I cannot make smaller. So my factors are, and I always write them from smallest to biggest, 2, 3, 5. And then my prime factorization, I take 30 equals 2 times 3 times 5. And how many? There's only one of each, so I just leave it like that. 45. Ends in a 5, so I know it's 5 times something. 45 divided by 5 is 9. 9 is 3 times 3, and I can't make those smaller. So my factors are 3 and 5, and my prime factorization is 45 equals 3 times 5. How many 3's? 2 of them. How many 5's? 1. Okay. Now, true or false? Is 7 a factor of 63? I don't know. Well, 3 can go into this, so I have to go 63 divided by 3, 21. 3 is the smallest it can get. 21 is 3 times 7. So my factors, I don't have to write it. I have to say, is 7 a factor of 63? I can see 7, so I say yes, it's true, because it says true or false, because I see 7 here. 29. Let's see, what are the factors of 29? Well, I can't divide by 2 because it's not even. What about 3? No. What about 4? No, it can't be 5. What about 6? No. 7? 8? 9? It can't be 10 because it ends in a 9. 11? No. Oops. 29. What about 12? 13? 14, 15. I could keep going and nothing works. So if I look, nothing will work. So the only factors of 29 are 1 and 29 because it's a prime. This is a prime number. And if you check the little list of prime numbers I gave you, 29 is a prime number. Okay, so it says, is 9 a factor of 29? No, it's false. Okay. Another way to check is you can go, well, 29 divided by 9? No, it doesn't work. 9 does not go into 29. Okay. 8 is a factor of 28. So that's even, so I can divide by 2. 28 divided by 2. 14, and 14 is 2 times 7. Do I see 8 here as a factor? No, so this is false. Okay. The only factors of 17 are 1 and 17. Does anything go into 17? Well, let's go. 17 divided by 2. Well, no, it can't because it's not even. What about 3? No. 4? No. 5? Oops. If we check, 17 is on the list of prime numbers. So when it's a prime number, the only factors are 1 and whatever number that is itself. So it says the only factors of 17 are 1 and 17. That's true because that's a prime number. Okay.